Find the slant asymptote if any of the function f of x equals to x squared plus 4 divided by x. The degree of the numerator of this function n is equal to 2, and the degree of the denominator m is 1. Since the degree of the numerator is exactly 1 greater than the degree of the denominator, this function has a slant asymptote. The slant asymptote is the quotient of x squared plus 4 divided by x, which is obtained by using long division. The long division can be performed by arranging the numerator and the denominator as shown here. X times x is x squared. Subtract, which cancels out these two terms. Bring down the next term, which is 4. Since this number no longer has the variable x in it, the division stops here. And this gives you the remainder, and the quotient is x. And so the slant asymptote is y equals to x. Given a function f of x equals to x to the 4 minus 8x cubed plus 4x squared plus 6x minus 3, use remainder theorem to find f of 2. The function f of x is arranged in the descending powers of x. So we'll use synthetic division to divide the function f of x with 2. Write the coefficients of f of x as shown here. And bring down the first number 1, multiply 2 and 1, and place it under negative 8. Add the numbers negative 8 and 2 to get negative 6. Now multiply 2 with negative 6 and place it under 4. Add the numbers 4 and negative 12 to obtain negative 8. And then multiply 2 with negative 8, place it under 6, add the two numbers to get negative 10. And finally multiply 2 with negative 10, place it under negative 3, and add them to get negative 23. This last number is the remainder. From the remainder theorem, if f of x is divided by x minus c, the remainder is f of c. And so the function f of x evaluated at x equals to 2 gives you the remainder. And so f of 2 is 2 to the 4 minus 8 times 2 to the 3 plus 4 times 2 to the 2 plus 6 times 2 minus 3, which gives 16 minus 64 plus 16 plus 12 minus 3, which simplifies to negative 23. And so this verifies the remainder from the synthetic division.